Hello and welcome to the Rasa 3.0 launch event. We are very happy to get started here. Sorry for a little bit of a delay this morning. So we're going to start off talking about one of our larger changes, which is an architecture update. And there is a quick update on the content for this week. Tomorrow morning, my time, we have on the schedule in office hours with Ty and Yusta. They will also be joined by Tobias and Joe, and they will be fielding general Q&A questions, but also any questions that you have about the architecture update. So with that in mind, let's learn more about the new Rasa architecture.
Hello, I'm going to be talking about the new Rasa 3.0 architecture. Let's begin by discussing the motivation behind doing this change now. Rasa was initially built with a very specific model architecture in mind. But as we've grown as a framework, a company, and a community, the kinds of models we want to build with Rasa have outgrown this initial approach. As we tried to accommodate more and more different kinds of models and components, we had to introduce more and more complexity into the code base. And once your abstraction no longer matches your problem, it's time to find a new abstraction. We need an architecture that was flexible enough to handle different kinds of models we know about now, but also resilient and flexible enough to handle what may come in the future. To explain this, let's take a look at how Rasa works pre-3.0. The architecture of Rasa really boils down to two separate parts: the NLU pipeline and the core dialog policies. The NLU pipeline is a linear series of components designed to extract data from and classify a single user message. The core ensemble is a collection of policies that try to predict the next bot action based on the past conversation and the newly classified user message, which is the output from the NLU pipeline. The Rasa codebase is literally split into NLU and core, and the divide between these two sections runs throughout the entire framework. This is how the majority of models work, so it's done us pretty well for a long time. But then end-to-end training came along. End-to-end training was a new feature added to Rasa, which allowed the policies to predict the next action directly using messages, i.e. going directly from user text to bot response, and skipping the NLU classification. However, this means that the TED policy now needs access to certain NLU features. It has to featureize the user messages before it can use it in its prediction. As you can see in this diagram, we now have connections between the two parts. So it broke this abstraction and this separation that had always existed in Rasa. Adding this feature caused a big strain on the code base and was one of the main reasons that led us to start developing the new architecture. So let's talk about how things are now in 3.0. Once you tear down the boundaries of NLU versus core, what you can see is that we have a collection of components, some of which require data from previous components. If we think of components as nodes, and the dependencies or the data flow between them as edges, we end up with a graph. The graph isn't opinionated about whether something is NLU or core, it just cares about which components rely on the output of which other components. The data flow and dependencies are now explicit. Not only are they explicit, but they can also change for each model, depending on how we want the architecture of the model to look. I.e. we can easily have a more traditional model with a split between NLU and core, or we can have a model which works using end-to-end policies. We can also add new kinds of components and new kinds of architectures without having to change the fundamental code base of Rasa, as these graphs are represented as data which is stored in each model. Another big advantage is that it allows us to be clever about which components we have to retrain when retraining a model. If we change one component, we only have to retrain that component along with any components that depend on its output. If we change the configuration of the count vector featureizer 2, we only have to retrain that component along with components that actually use the data it outputs. So here, the diet classifier and the TED policy, because this is an end-to-end architecture. Now I'm going to give a quick demo of how this enables us to actually make use of this with caching when retraining models. I've set up a basic Rasa project using Rasa init, and I'm using Rasa 3.0. The config is essentially the default config created by Rasa init, the same with the various training data files. Let's do an initial train. If we look in the logs, we can see each component training individually. And the model is trained and saved in the archive. Something else worth noting is a new directory has popped up called .rasa. This is where we store the cache. If you look inside, you can see various funnily named directories and an SQL-like database. These directories contain the artifacts and saved model data from the components. And this database is a way of mapping fingerprints of a component's run to the outputs they created when training. The fingerprint of a component is a combination of the configuration of that individual component plus signatures of the data that it uses as inputs. If we combine these things, we can come up with an unique representation of an individual run of a component. And if none of those things have changed, we know that we can reuse the cached output from the last running. Let's change the config of one of the components to show how this works in practice. So I'm going to change the config for the second count vectors featureizer in the NLU pipeline. In Rasa 2.0, this would have meant retraining the whole model as we changed the config. However, if we try it here with Rasa 3, we can look at the logs and see these components here at the start, so a regex featureizer, first count vectors featureizer, etc., have been restored from cache rather than retrained. This is because the input to these components, so the input to the white space tokenizer, for example, is the NLU data, which hasn't changed. And the config also hasn't changed for white space tokenizer, so we can assume that the output is going to be the same as last time. The input to a regex featureizer is the output of the white space tokenizer. So as we know, the output to a white space tokenizer hasn't changed, and we know the config of a regex featureizer hasn't changed, we can then assume that this also will be the same. However, the second count vectors featureizer does have to retrain because the config was changed. And subsequently, components which depend on the output of the count vectors featureizer, i.e. the diet classifier, also have to retrain as one of their inputs have changed. And as we said before, the fingerprint of a component is a combination of its config plus its inputs. And this is all possible because now we represent our model architecture as a graph, so the dependency between components is explicit. Now we can take this a step further, show that it doesn't just work when changing configs, but also when changing the actual data that flows. So to use an extreme example, I'm going to change something in the domain. So here in the domain we have the bot responses. Now in Rasa 2.0, if we changed a bot response, we'd have to retrain all the policies because we were unable to determine exactly what data was being used for what. We just knew that the domain was used. However, now we can be a bit more clever about this. So let's change the value of the utter greet response. And then retrain the model. As you can see from the logs, we haven't had to retrain any of the components. We've restored all of them from a cache. This is because the response text of a bot response is actually meaningless to the model that's training. It just needs to learn to predict a certain action which maps to a response. It's essentially a lookup. This is going to be especially useful for large projects which take a long time to train. It allows us to change small things and retrain the minimum amount of components each time, based on exactly what each component needs. Let's talk to the bot quickly to prove that the text has actually changed. And we see the new response. Another benefit that we have in 3.0 is that the cache is now separate from the models. Previously, we would try and determine what had to be rerun by looking inside the latest previous trained model, where we stored certain fingerprints of input data and we tried to figure out what had changed. Another limitation of this was that we were only able to compare with one previous model. However, now the cache is separate, we can make use of these cached component trainings, multiple trainings in the future, which means when we're experimenting and trying different things, whenever we end up with a situation where we'd be retraining something exactly the same as it was trained before, we're always going to make use of the cache and speed up the training. So what does this mean for Rasa developers and people building bots? The config file will remain essentially the same. However, we need a way of building a graph from a config. And this is where recipes come in. A recipe defines config format and the model architecture which will be built from that config. And it allows us to move from the config to the graph. To begin with, we're only going to have one recipe, the default v1 recipe. And this essentially uses the current model config you'll be used to from Rasa 2.0 and turns it into a graph which runs in Rasa 3.0. You have to include this recipe key at the top of the config so we know how to build it. And in the future, as we experiment with more different kinds of architectures, we can have different recipes which will have different config formats and result in different architectures. Custom components now have to have a common interface. This is called graph component, and it's a Python abstract base class. So if you're using custom components, you'll have to update it to inherit from this interface for it to work. We've also made a few changes to how components work. One of the big ones is that we've changed how component persistence works. We've abstracted and unified component persistence to use this new object called model storage. It's not difficult to change a component to use it, but what it means is that we can now control at global level how artifacts from components are stored, which helps us to manage things like very large data sets or using more complex setups for storing data rather than just your local machine. Components must also be registered with recipe now. You can see all of these changes in the migration guide. There's already some resources out there if you're more interested in reading more about the new architecture. So there's a really good blog post by Vincent called Bending the ML Pipeline. There's also a whole new updated doc section about custom graph components if you're interested in how it actually works under the hood. And there'll be a lot more to come, videos and blog posts. Looking forward, you can expect much more different research experiments, different architectures like multi-bot architectures, and also performance increases, especially when training with large data sets. And this architecture is really just a foundation for what's to come. This will enable us to experiment much more freely in the future and to tackle big problems like training performance with large data sets. Thank you very much for listening. I can now take any questions you may have.
Hi, and by now, Joe means tomorrow morning during the architecture-focused office hours. Thank you so much, Joe. And I hope you all are very excited about this graph architecture. It's modular, it's going to reduce training times, which I know everyone wants that, right? And should enable a lot of cool stuff in the future. So if you have other questions on that, feel free to pop in tomorrow morning Pacific time, so around the same time as this, for our next office hours. So we talked about the architecture. Another big change in Rasa 3.0 is the way that we handle slots. And this has been an area of persistent confusion and also some deeply frustrating bugs for our users. So we fixed it. Let's learn a little bit more about how from Anca. Here we go.
Hello, my name is Anca and I'm a junior engineer at Rasa. I will be walking you through the slot mappings improvements in the latest 3.0 version. Let's get started. Firstly, let's talk about the motivation behind the change. In 2.0, the two mechanisms for slot filling, such as the implicit mechanism of slot autofill with the entity of the same name, and the explicit mechanism of filling slots when requested by forms, led to issues such as unexpected behavior when forms were not requesting an autofill slot if this was set before form activation. Slot mappings had to be duplicated across multiple forms. Slots could not be kept up to date throughout the conversation. To solve these limitations, we introduced a single explicit mechanism for slot filling by automatically running the new default action extract slots, after every user turn. This action fills slots if the slot mappings defined in the domain apply. To enable the slot filling mechanism, we introduce breaking changes in the domain, which we'll talk about shortly in the next slides when we migrate a 2.0 domain to 3.0. This feature unlocks more applications as it allows slots to be updated throughout the conversation, and it removes duplication of slot mappings in forms. Let's try to migrate a 2.0 domain to the 3.0 format. On the left-hand side, we have a domain that contains a slot outdoor seating, which is part of the restaurant form required slots. The slot mappings on the left-hand side will be moved into the mappings key of the slot outdoor seating in a 3.0 domain format. Optionally, you can add mapping conditions that can include active loop and requested slot. The form required slots field will collapse to a list of slot names, such as in the example on the right-hand side. Okay, now it's demo time. I have prepared a simple travel bot that will list a few cities according to the activity that the user specifies. In the domain, I have three entities: activity, city, and email. I have a slot location that will be filled by the entity city, a slot email address, which will be filled by the entity email, activity type slot, which will be filled by the entity activity, and a has booked slot, which has a custom slot mapping. This will be extracted by using the action validate slot mappings. In forms, I have a booking form, which will ask for location and email address. Let's have a look in actions. Here I have extended the validation action class available in the SDK. I can validate location by looking up the slot value in the location DB. If there's no match, then the location will be reset to none. With hasBooked extraction, I check if the slot's location and email address have been set beforehand. If these have been set, the hasBooked slot will be set to true, otherwise it will be reset to none. Let's see how a conversation looks with the bot. First, I'll say hi to the bot, and the bot will respond back by asking me to choose my preferred activity type. Once I've selected my choice, the bot will respond with the conditional response variation that matches the slot value for activity type, in this case outdoors. In 2.0, this used to be less straightforward because the user had to first trigger a form to collect information for the slot activity type. In 3.0, this can now be done without forms. Next, I'm triggering a form by asking to book a trip. The form will ask me for location and email address. And then it will deactivate itself once all the details are submitted. In the next response, I then change my mind and want to update the email address. It is now possible in 3.0 to update slots as the conversation progresses, as I just did with slot email address. Before we wrap up, I wanted to draw your attention to a few feature aspects. Action extract slots runs automatically at the end of the NLU pipeline and before the dialog manager. The slot autofill from entity with the same name was removed in 3.0. To maintain 2.0 form behavior, use mapping conditions in the slot mapping. To customize your slot extraction and validation, use the slot validation actions such as action validate slot mappings available in the Rasa SDK. To recap, 3.0 slot mappings enable slots to be set in any context and updated through the conversation. If you'd like to learn more about the domain breaking changes and how to migrate to 3.0, please visit the Rasa docs. To learn how to customize slot extraction and validation, visit the Rasa SDK docs. Thank you for listening.
Great. Thank you so much, Anca. I know that in particular, updating slots in the middle of a conversation has been an area of significant pain, as those of you who spend a lot of time on the forums have also probably encountered from other folks as well. So you may have noticed that for the last little bit on our YouTube channel, we've been talking a lot about evaluation, how to make sure you know your assistant is working, how you make sure you know it's working in context. And we definitely appreciate that everyone could use more tools to help with that. And one of the new tools that we have been working on is a feature which is experimental in 3.0, and it is markers. And here to talk about it a little bit more is Anca. Nope, Aciel. Anca just talked. Here you go.
Hi, my name is Aciel, and I'm a senior machine learning researcher at Rasa. Today I'll talk to you about a new experimental feature in Rasa 3.0 called markers. One of the main questions we receive from our community is, how do I evaluate my bot? Or how do I know how good my bot is? One way to answer this question is by evaluating the different components that make up your bot. For example, you can measure the accuracy of intent detection, entity extraction, and action selection. However, the accuracy of these individual components doesn't tell you how well your bot performs as a whole and on the task it was built for. For this, you need to instead define and measure your bot's key performance indicators, or KPIs. And these are things like task success and failure, dialogue completion, and human handoff. And this is where the markers feature comes in. Markers does two things. It gives you a language to describe important events in your dialogue, and a method for recording when these important events occur. More precisely, markers are conditions defined over events and applied to the dialogue stored in your tracker store. When the conditions are met, the dialogues are marked for further analysis or inspection. Let's look at an example together. This is an example of a marker definition written in YAML. It specifies task success for MoodBot. This is the bot that you get when you type the command Rasa init. MoodBot is tasked with cheering up users when they express an unhappy mood. And what this marker says is, mark every occurrence of the following sequence of events, where an intent, mood unhappy, has been detected, followed by actions utter cheer up and action utter did that help, and finally followed by the intent affirm. Suppose you have the following dialogue sequence expressed at the text level and also at the event level. The user says hello, and the bot says hi, how are you? And the user says I'm sad. And the bot says here's something to cheer you up, did that help? And the user says yes. This marker will apply at the final step when all the conditions are satisfied. Suppose we have a different dialogue sequence where the user answers no to did that help. In this case, the marker would not apply. In addition to defining and tracking your KPIs, you can also use markers to diagnose your dialogues. For example, suppose you notice a negative pattern in one of your dialogues. Maybe your bot attempted to cheer up a user after they've expressed a happy mood. You can describe this pattern with a marker condition and apply it to your dialogues. This would allow you to quantify how often this pattern occurs and surface relevant dialogues for inspection as part of conversation-driven development. Let's look at a quick demo of markers to see how the feature works and what the output looks like. This is a Rasa init project that I've already created, and I've already trained my bot. In the endpoints file, I've already specified a tracker store, and I'm initiating it with the following command. This created a tracker store called trackerstore.db. Now I'm using Rasa shell to populate my tracker store with dialogues by interacting with my bot. I created 3 dialogues following different sequences of events. I then created a marker configuration file called markers.yaml, containing one marker that defines task success for MoodBot. I can now run the command Rasa evaluate markers. The argument all says to process all the trackers in my tracker store, and out.csv is the markers output file. Running this script has produced 3 files. The first one contains the occurrence of each marker in my marker configuration file. In this case, I only had one marker, and it only occurred once. The other 2 files contain summary statistics about markers. You can find out more about their content in the docs. To conclude, I'd like to emphasize that markers is a feature that we're very excited about at Rasa because it lays the foundation for evaluating bots and is the first of many steps that our research team is taking in this direction. At the same time, we're releasing it as an experimental feature first and would very much like your feedback. So please try it out and let us know what you think. For full details on usage instructions, including how to construct marker conditions, please visit our docs. And for a tutorial, please check out our latest whiteboard algorithm video. And this brings us to the end of the talk. Thanks for listening.
Great, thank you, Aciel. Excuse me, I should have cleared my throat before I switched. So markers are, just as a reminder, what Aciel said, an experimental feature. If you have any feedback, if you have any issues, our GitHub is a great place to provide issues. And if you have any specific questions that aren't answered in the docs, I would head to our forums to ask that. So those are the three major updates that were part of the Rasa 3.0. So that was the architecture update that Joe talked about, the slot update that Anca talked about, and then finally the markers update that Aciel talked about that is experimental. But we also had a couple other smaller updates that are still going to be really helpful and valuable. And here to talk about the first one, OR slots, is Alexander. Here you go.
I'm going to be talking about a small but useful feature we call OR slot values. Let's first talk about the problem and how things worked before Rasa 3.0. It was only possible to use one slot value per slot was set step or condition. Let's say we have a categorical slot that can have two possible values. In this case, that's a slot called name, which can have values Joe and Bob. In test stories, you can have a step slot was set, which allows you to train the model on slots being set. This is how the story might look like. As you can see, you can use slot was set and you can check that the slot name should have been set with the value Bob. Unfortunately, if you want to check that the slot name has a value Bob or Joe, then you need to write two stories, which is of course not very critical in this particular case, but can be problematic if you have multiple categorical slots or slots that can have not just two possible values, or if you have some more complex logic. We decided that it would be useful to be able to use OR in slot values, which basically means least multiple options that all qualify for this step. As you can see in this example, we used OR to specify that the value can be either Joe or Bob. But why did we choose this syntax? Because it was actually already possible to use it with intents, so we've basically just made it possible for slot was set to also be used with OR. Of course, we also made all the documentation changes, and you can find the information about OR statements in the corresponding section of documentation for stories. That's it. Thank you for your attention.
Great. So a pretty small update, but again, just brings slots in line with intents, and I can think of a lot of uses for it, and hopefully should result in y'all having to write fewer things by hand, which is a great goal in my mind. So for our final video in the series, we have Tobias, who is talking about a number of smaller changes that we made as part of the 3.0 update to improve quality of life generally. So here's Tobias with quality of life updates.
Hi, I'm Tobias, and I want to talk about a couple of improvements in Rasa Open Source 3.0 which will make your life as Rasa developer easier. As you have just seen, Rasa Open Source 3.0 comes with a lot of big and exciting new features. However, we've also done a series of smaller improvements all around the codebase, which I believe will make your life as Rasa developer easier. In this section, I want to focus on three of them. First, we've improved how models are named in Rasa Open Source 3.0. This makes the models easier to distinguish for you and also easier to remember for you, which in turn makes it easier to talk about the models with your fellow humans. Further, we've done a couple of improvements to really allow you to take conversation-driven development to the next level. This allows you to do more advanced analytics on the gathered conversations by your user. Last but not least, we're working on making Rasa ready for the future and for more features to come. Hence, we have added support for new TensorFlow versions and are working on support for future Python versions. Let's start with the first point. With Rasa Open Source 3.0, it becomes easier to identify and distinguish model names quickly. As you can see on the left side, model names in Rasa Open Source 2 used to consist of a single timestamp. This made the model names unique, but also made them very hard to talk about them with other fellow humans. Rasa Open Source 3.0 mitigates that. On top of the timestamp, it will now also contain a randomly generated name. This makes it easier for you to distinguish models quickly and to remember their names. For this feature, we have collaborated with the maintainer of a library called Random Name. We Rasa developers have contributed to this library. I think this really shows how the open source community can support each other and thrive together. With Rasa Open Source 3.0, we are really taking conversation-driven development to the next level. We are doing this by adding more prediction metadata. Every Rasa model now has a unique ID baked into the model archive. This means even if you rename the model archive or move it around, this unique ID will still stay consistent. Every prediction made by your model will reference this unique ID. You can see an example on the right side. As you can see, it contains a value metadata, which consists of a field model ID, which references a unique model ID. This allows you to tie model predictions to your model which made these predictions. This, for example, allows A and B testing and allows you to do advanced analytics on your gathered conversations. 3.0 is already the third major of Rasa open source. For such a code base, it's important to stay maintainable and navigatable for the future. A year ago, we introduced the YAML training data format. We now believe that YAML training data is ready to replace Markdown fully. After deprecating Markdown earlier this year, we have now fully removed it from the codebase. This removes a lot of code and weight from the codebase, making it easier for us to maintain it in the future. Further, we've updated the version of one of the machine learning libraries, which is at the core of Rasa open source, TensorFlow. TensorFlow 2.6 closes a lot of security vulnerabilities and makes your Rasa deployments way more secure. We are currently also working on adding support for TensorFlow 2.7 and will add support for it soon. In Rasa Open Source 3.0, we also remove support for Python 3.6. Python 3.6 reaches its end of lifetime at the end of this year. We've already started to make Rasa open source compatible with Python 3.9. Support for Python 3.9 will be in one of the next releases. Rasa Open Source 3.0 has a lot of small improvements like these. Improving the model naming, adding support for advanced conversation-driven development, and making Rasa open source ready for the future are just some of them. I'm sure you will enjoy all these little gems, which are part of the Rasa Open Source 3.0 release. Thank you.
Great, thank you, Tobias. So that is going to be the last thing that we have for this launch live stream. We've talked about our major updates, the architecture update, the slot update, and also the second part of the slot update, which is OR slots, and the marker update, and then a number of smaller fixes and updates that we have included in 3.0. And I'm sure you all have a lot of questions, so we have some office hours later this week so that you can get those answered live. You're also, of course, always welcome to ask on our forums. So tomorrow morning, it's going to be, and this will be updated, Justa, Ty, Tobias, and Joe. So answering any general questions or questions that you have specifically about the architecture update. Followed by a office hour with me and Anca, again answering general questions but focusing on slots and the slot update, so if you have any questions about that. And then on Wednesday we're going to be having office hours with Vincent and Aciel talking about markers, so if you had marker questions, that's the one to tune into. Again, also happy to answer general questions. On Thursday, there will be live coding with me. I'll be making a new Rasa 3.0 assistant from scratch, so you can walk along with that process with me. And then on Friday, I'm very excited, our fabulous community manager, Emma, is going to be doing a community-focused stream talking about the different ways that people contributed to Rasa 3.0, ways you can contribute in the future, all sorts of fun stuff, and I'm really looking forward to all of that. So thank you so much for joining today. If you have any questions, please head to the forums or feel free to ask in our office hours the rest of this week. And we hope you really enjoy 3.0, and we will see you later. Thank you so much. Bye.